I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll introduce exponential functions, a lesson with a very bright student of mine, Rohan, who is a topper in his class. In case you want to learn from me, you can also send an email on the address given here. Now, let us enjoy learning and the journey of success. Hi, Rohan. How are you doing?
I'm good, sir. How are you?
Very good, very good. So, today, what do you want to learn?
Sir, I would like to learn about exponential functions and then how it can be transformed, like transforming it from one place to another.
Okay, transformation exponential function. Definitely, we'll do that. So, let me share with you a whiteboard and then we'll begin with exponential functions, right? So, let me give you three graphs and then you can tell me which one represents an exponential function. For example, this graph represents what?
A linear, quadratic, exponential.
Yeah. So you see, exponential function increases all the time, right?
Yeah.
Just as a line increases, right? You have this linear function which is increasing. Similarly, the exponential function is increasing. How? In a line, the increasing rate is constant. It increases at a constant rate, correct?
Okay. So
But
like a
it
linear.
increases at higher and higher rate, right? You see, at any 2 points, if we draw a tangent line, right, then the slope of the tangent is different. You get the idea?
Yeah.
So rate of increase increases. So here we have a rate of increases is constant. Is it okay?
Yeah.
And here rate of increase increases. Rate of increase you can find by finding slope of a tangent line at different points, right? So if you take any 2 points on the line, you'll find the same slope, right?
Yes, sir.
Here, if you draw a tangent line, you see the slope here and the slope here. There's difference. Do you see that?
Yes,
Change
sir.
in y to change in x is much higher as you move towards right. Positive.
Yeah.
Can you describe the rate of change for a quadratic function x squared? How does the rate of change changes for a quadratic function?
When it changes by having the same increase as constant but on both sides and
No,
it's evenly apart.
no. You see, it is negative here, right? You see that?
Yeah.
So rate of change goes from negative to 0 here to positive,
Positive.
right? So in
Oh,
fact, rate of change is always increasing here also. Rate of change is increasing here also, right?
yeah.
At a constant rate. It goes from negative to positive. Here, the rate of change is constant. You understand the difference.
Yes, sir.
I will just make you understand the difference with the help of table of values. Okay, that's very interesting. Let's look into that now. Let's take three different types of functions. One I want to take as linear. Then I want to take quadratic. And then exponential. So let's take some x values and write down some y values with which will have a constant difference, right? Linear function, right? For example, if I have a value like 0, 1, 2, 3. And in that case, let's say y values are 3, 5, 7, 9. Correct?
Yes, sir.
In this case, it is linear. How do you know it is linear?
By doing a subtraction of both, you get the same answer.
Yeah,
Two.
first difference, right?
Yeah, first
First
difference.
difference is constant, right? You see the constant
Yeah.
rate of change. Do you see that?
Yes, sir.
Means delta y over delta x is constant, right? In this case, it is equal to 2, correct?
Yep.
Change in y is 2 and change in x is 1, right? So we
One.
are saying delta x equals to 1. So change in y is your rate of change. Now let's take some values. Y equals to x squared, that be quadratic in nature, right? So let's say 0, 1, 2, 3. Then we have 0, 1, 4, 9, correct? Square, quadratic, correct?
Yeah.
So for the same values, 0, 1, 2, 3, the quadratic function will have 0, 1, 4, and 9, square of the number. Now, if you find the first difference, what do you find? 1 minus
1,
0, 1. And then,
3, 5.
well, if I would write 4, 16, here you get 7. Do you see that?
7.
So here, you see it is always increasing, correct?
Yeah.
Increasing with a different number,
Number.
right? So 1, 3, 5, 7, right?
Yeah.
So the rate of change is always increasing, but with a different number. But the second difference you find is constant. You see that too?
Yeah. 2, 2, 2.
The second difference is constant. Second difference is constant. That means we can say second difference. Constant second difference. As far as the first difference is concerned, it is changing at a constant rate, right?
Yeah.
So it is 1, 3, 5, 7, correct?
Yes, sir.
So it is changing. What you can say 2n plus 1, correct? Constant rate, 2n plus 1, right? So n equals to 0, 1, n equals to 2, 3, right?
Yeah.
It's changing. First difference is changing at constant rate. Not same. Now, if I do the same thing for an exponential function, then what values do we get? Let's see. X, and let's say 2 to the power of x for simple calculations. 0, 1, 2, 3, 4. So what is 2 to the power of 0?
0.
1. Anything to the
1.
power of 0 is always 1. 2 to the power of 1 is how much? 2.
2.
2 square is 4. 2
4.
cube is 8. And this is
8.
16. You see that?
Yes, sir.
Clearly, the first difference is not constant, and even the second difference is not constant, correct?
Yes, sir.
But what do you notice? Every difference is times 2. So it is times 2. Every number is times 2. The previous number, correct?
Yeah. It's
If I
double.
take the first difference, I'll get 1. Let me write down the difference also to be very clear. Difference is like 2 minus 1 is 1. 4 minus 2 is 2. Then this is 4. And this is 8. Correct? Do you see that?
Yeah.
Difference is times 2 multiplied. This is what we call exponential growth, which is like this. Much steeper, faster. Is this clear to you?
Yes, sir.
So from the data, you can find from the first difference itself, whether it is exponential or not, whether it's linear or not, whether it is quadratic or not, correct?
Yeah.
If it is linear, you get the constant first difference. If it is quadratic, then it is increasing by a constant term, which is plus 2 each time.
Plus 2.
First difference, right? And here it is product
Double.
multiplied by, right? Doubled or tripled depending on the base. Since our example was 2 to the power of x, it was multiplied by 2 each time. You get the idea?
Yes, sir.
If it was 3 to the power of x, then we multiplied by
3 times.
Correct? So the product gives you an idea about the base of the exponential function. Is that clear to you?
Yes, sir.
Right. So that's how it is. So I hope you have understood the difference between linear, quadratic, and exponential function, their graph, and also their equations. Perfect?
Yes, sir.
Now, let's try to sketch exponential functions. To keep it simple, we'll begin with 2 to the power of x and just plug the values in and sketch the graph. So let's say x values, and we'll write 2 to the power of x. Y equals to 2 to the power of x. So let's take 0. So 2 to the power of 0, as we saw, was 1.
1.
1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. If it is minus 1, then 2 to the power of minus 1 is how much? Tell me.
2 to the power of minus 1 would be negative 2.
No, it's half. 2 to the power of minus 2 is 1 over 4, and minus 3 will be 1 over 8. As you can see, it decreases, correct?
Okay, sir. So it never become a negative, it just go
Always
into a
positive.
fraction.
Yes. So if you sketch the graph, it is going to look like this. So this, as x approaches negative infinity, y approaches 0, but it is
0.
always positive. You see that?
Yes, sir.
And we call,
So,
because it is approaching 0, we say y equals to 0 is horizontal asymptote.
okay. And would the domain be x of real numbers and range would be y of real numbers, where y is greater than 1?
0.
Oh, 0.
You're right. Where y is greater than 0. It is never 0. Is it okay? It's
Okay.
always positive, non-negative, right? Greater than 0. Is that clear to you?
Yes, sir.
Now let's look into some characteristics. So if it is y, we sketch the graph of 2 to the power of x. You notice that when x is 0, the value is 1, right? When x is 1, then the value is half, 2. And when x is minus 1,
Yes.
then the
It
value
is half.
okay, reciprocal.
Yeah.
Minus means reciprocal. So the graph is kind of as shown here. Now these three are critical points, key values, which can help us graph exponential functions, right? So we normally look into these values of x to sketch the graph of an exponential function. Okay?
Yes, sir.
One very important value also is when x approaches negative infinity, then y approaches 0 from the positive, and that is the horizontal asymptote, correct?
Okay, sir.
So you can look into horizontal asymptote and these three key points to sketch the graph of an exponential function. Perfect?
Okay.
Now, if I have to sketch on the same graph 3 times 2 to the power of x, how will that graph be? Can you tell me?
2 to the power of x, sir?
Yeah.
So
3
if
times
it's
3 times 2 to the power of x.
so if it's 0, it would be 3.
Correct.
If it's 1, it would be 6.
Correct.
And if it's negative 1, it will be 1/6.
No, 3 over 2.
Or 3 over 2.
So you see the graph actually becomes steeper. You see that? But
Yes,
still
sir.
it is going to approach approach 0 when x is approaching infinity, minus, right? And when x approaches positive infinity, y approaches positive infinity, correct?
Okay.
So if I multiply by a factor which is greater than 1, the graph gets vertically stretched, correct?
Yeah.
Correct. So now we can look into the transformation of this function. Let me clear this. So for transformation, last time we did the function, let's say g of x is equals to a times a of a function k x minus p plus q. So the transformation rules are exactly same as we did for other functions. If the function is exponential, then this function is exponential. We could write this as a, let's say it's some b to the power of k x minus p plus q, right?
Yeah.
So that becomes an exponential function. Now, I'll give you an exponential function. You tell me the transformations, okay?
Okay,
Let's
sir.
say we have a function h of x equals to 3. Let me make this as 2 times 3 to the power of 2x minus 1 minus 5. Can you explain the transformations of this function?
So h of x is equal to 2 in brackets 3 to the power of 2x minus 1 in brackets minus 5, sir.
Correct.
So the graph is vertically stretched by a factor of 2.
Correct.
It is shifted 1 unit to the right and 5 units down.
Correct.
And it is horizontally compressed
Correct.
by a factor of 2 or
Ah, only thing that your order was not correct. Your order should be always correct when you explain the transformations, okay?
yes, sir.
Multiplications of products should be followed by translations. Is it okay? So reflections, stretch, or compressions followed by translations. Clear? So as I have
Yes, sir.
written, you could actually go from left to right. Vertically stretched by a factor of 2, horizontally compressed by a factor of half, translated 1 unit right, 5 units down. Is it okay?
Okay, sir.
Now, can you tell me what is going to be the horizontal asymptote for this particular function?
Would it be 0, sir? Why?
Y equals to
Oh,
minus
negative.
5. Because the whole graph moves 5 units down. Horizontal asymptote, which was y equals to 0, also moved 5 units down, correct?
Yes, sir.
So therefore, the horizontal asymptote will be y equals to minus 5. Is that clear to you?
Yeah.
So if you sketch this function, it could look something like this. Perfect?
Okay, because it shifted 5 units down, right, sir?
And 1 unit to the right. Correct?
Yeah,
So
okay,
that
sir.
is how it could look like. You can always transform the points and get the graph, right?
Yeah.
Let's do one more question. Let's say p of x is equals to minus half 3 to the power of 2x minus 4 plus 1. Can you tell me transformations for this function?
It is vertically compressed by a factor of half.
Correct?
By a factor of half. It is compressed by a factor of half, like horizontal.
Horizontally. Yes, what else?
It is shifted 4 units to the right and 1 unit down.
That is wrong. So what you need to do is you have to factor out this 2. So when you do that, you get minus half, and this is 3 to the power of, factor out this 2. You get x minus 2. Get the idea? Plus
Okay, sir.
so translate it 2 units right and 1 up. Is that clear? You missed one thing, and that is negative. What will this negative do?
It would be opening downwards, sir. Or reflect.
Reflection on the x-axis. You get the idea? It reflects
Yes,
on
sir.
the x-axis. Perfect. So if you want to sketch the graph, how will you sketch this graph? Can you tell me, please?
It would be 2 units to the right and 1 unit up. So therefore, it would be it wouldn't be as steep, sir, because it is compressed by a factor of half.
Yes.
And then reflected on the x-axis.
So what you could do is you could find the table, write down the value. Is it okay? So if I consider the function 3 to the power of x, and now this function, which is minus half 3 to the power of 2 x minus 2, I'm writing now, plus 1. Can you tell me what kind of transformations, how do you write the coordinates, image points? If xy is on the parent function 3 to the power of x, how is this going to change as the image on the transformed function? What will happen to the x points? Tell me.
It would be half x minus
Plus
2,
2.
I mean plus 2 by
And y points will be minus half y plus
minus half by plus 1.
correct. So let's write down the key points for 3 to the power of x. So if it is minus 1, in that case, it is 1 over 3, correct?
Yeah.
At 0, it is 1. At 1, it is 3. Is it okay? And also, we know that the horizontal asymptote is going to be y equals to 0.
Y equals 0.
Now, just consider these 3 points and the horizontal asymptote. Can you tell me the new points? Work it out.
If it is 2, it would be
No,
2 and
no, minus 1. If it is minus 1, then what happens? Just plug in minus 1.
oh, if it's minus 1?
Yeah.
Okay. So half of minus 1 plus 2 would be negative half of 2, so that is 3 over 4. And if it's 1/3, then y would be negative half multiplied by 1/3 plus 1. That would be, so negative half multiplied by 3. It would be negative 1/6 plus 1. So that would be 5 over 6.
So when you plug in minus 1, so minus 0.5. So 2 minus 0.5 is 1.5. So I wrote 1.5. And 5 by 6 for the y value, correct?
Yes, sir.
When you plug in 0, you get 2 for the x value. And the y value will be 1 minus half, which is half. Is it okay?
Half. Yeah.
And to plug in 1, it will be 2.5.
It'd be
And you write 3. Then 1
3.
minus 3 by 2, right?
Yeah.
So 1 minus 3 by 2 will be minus half, correct?
Minus half.
So horizontal asymptote. Where will the horizontal asymptote be? Y equals to 0. What will happen?
0,
Y equals to 1 will be the horizontal asymptote.
1.
When you plug in 0 here, you get 1. Correct?
Okay, sir.
Now plot these points on a graph paper, connect, and then draw the line curve for exponential function. Is that clear?
Okay, sir. So if it is 1.5556 negative by half 2.5 by negative half. So if it's starting at, if it's 2 units, so 2 units generate 1 unit up. So this is where it is. If it's 1, 2.5 by negative, if it's 0 and 1, 2 and negative half. If it's negative 1, 5 over 6. So I'm not sure if this is correct, but when drawing it, I got this as my answer. Here.
No. It is going to go downwards as I have shown, right? So the graph originally was kind of like this, right? Correct?
Yeah.
So it actually went downwards, right? And then moved up.
Oh.
You see that? And translated. You see that? So that could be
Oh.
your graph. Do you understand?
Yes, sir. So it's 1/2. Sir, I redrew it.
Good. So now you know how to sketch the graph, right?
Yeah.
Perfect, perfect. So I would like you to summarize your learnings and then we look into some of my videos to answer the questions. Is it okay?
Okay, sir. So far today we learned about exponential functions. So how are exponential functions different from linear functions and quadratic functions as an example? As in a exponential function, the rate of increase is always increasing at a constant rate, meaning it's doubled. So if we look at, for an example, in a linear graph, there's always a first difference, so that's where the constant rate of change. And since linear is like y equals x, we found out that in the first difference it's all same, which means it's going constant. In quadratics, it was a bit different though. It was, instead of having first difference, it was second difference to find that it's constant. As in the first difference, we got different numbers, but when doing second difference, they're all the same. But when we look at exponential function, it's not difference, it's actually being doubled by the same amount. So for an example, it was to equals 2x, and like 0 was 1, 1 was 2, 2 was 4, 3 was 8, and so on and so forth. So each time it was getting doubled on the y side.
Because the parent function taken was 2 to the power of x. If we take 3 to the power of x, it will be multiplied by 3. So it
Yeah.
was times the base.
And then, like in sketching it, we found out that when x goes negative infinity, y just goes 0 from above. And when x goes to infinity, positive infinity, y goes infinity.
Correct.
And how the horizontal asymptote would always be y equals 0.
Correct.
To find out where it would be for the y-axis, along with knowing that the domain is always going to be x of real numbers, but range is always going to be y of real numbers, where y is greater than 0.
Correct. Perfect. So with that, you have good knowledge, but you need to review from your book and watch some of my videos. I'll share with you now some of my videos which can help you understand this topic better. So can you see my screen?
Yes, sir.
So here is the test paper on exponential functions. We just started today, but I like you to go through these questions and understand how to answer them, right? So we can go through their solutions if you want now. So these are, few questions. There are around 11 questions in this particular video. You can do some of them. I would like you to try all these questions. Submit your answers so that we can go through them in the next class. In case there is a difficulty in understanding any problem, feel free to share it by email or WhatsApp.